Hey guys, as much as I want to get back to finishing off this predictor in front of me, I realized I forgot some items in that recent spring finds series of videos. So I want to address that right now, because I think they're rather interesting. First up is this little guy, which is a multimeter, and it's unlike any one I've seen before. It's very, very colorful, as you can see in the manual here, which is a nice laminated fold-out manual. Let's see, who made this thing? Oh, it's Simpson. Huh. Simpson in the 80s, I would guesstimate. Alright, well, there's a little cover here. It just pops off. And here we go. Doesn't look like much, but I think it actually has some decent specs. It's true RMS. With a Digilog display, whatever a Digilog display might be. Looks to me like it's an LCD, but when this was made, that was probably a rather new thing. I'm guessing... I was going to say, I'm guessing this is battery operated, but I'm not sure. So this thing is weird in a number of ways. One, notice there are no input jacks on the front of it. Apparently they're on the side, and I'm not sure what kind it takes. I hope they're standard, otherwise I can't very easily play around with this. Let's see. I don't think this is going to fit on there. Nuts. They kind of look like they're banana plugs down in there, like the inverse of what I would expect to see. So you would need kind of like a hollow metal tube to slide over those. I'll have to poke around. First off, let's see, does this turn on? It's a little heavy, so I thought there might be batteries in it. Let's take a look. Put this back on, so let's scuff up the front while I take the back off. Well, I don't know anything about the history of the Simpson company. I know the most, as probably you guys do, for their volt-ohmmeter. I think it's the Model 260 that's just kind of everywhere. I think we had that in high school in our shop classes. And I've stumbled across a few other items like, well, that tube tester, the Simpson 330. I guess they were around for quite a while. Maybe they're still around, but they're nowhere near as prevalent as, say, a Fluke or a B&K. Ooh. It does have a battery in it. 9 volt. Luckily it hasn't oozed all over. Let's it does have a date. I think that's an install date. 11/15. That might be November 2015. And it's supposed to be good to December 2019. Let's do the tongue test. And that's actually got some juice left. This does have fuses, and there's a spare fuse included. It's a nice feature. They don't appear to be blown. Well, let's try powering this up again. See that it has a little buzzer beeper thing on the back. Maybe that's for continuity testing. There's also a little guide here in the bottom. Well, I can grab another 9 volt battery. I think I have a new one somewhere. Well, here we got the specs. So DC volts range 200 millivolts to 1000 volts. AC 200 millivolts to 750. DC current 200 microamps to 2 amps. Same for AC current, ohms, 200 ohms to 20 mega ohms. Wow, I'm surprised that bottom end is so high. 200 ohms seems a little Boy, I would want to get down to at least 10 ohms, and ideally less than that. That's not so good. Looks for continuity, their cutoff is 200 ohms and below. I'm guessing that means it has continuity, and 2K and above means it doesn't. Something like that. Peak hole, pulse detection, I'm not quite sure what those are. Curious about the true RMS. A company called Analog Devices that makes integrated circuits and some of the more unusual analog types made a true RMS converter chip. I think the AD536 or something like that. I'm wondering, did they use that or did they roll their own? So what is true RMS? Well, if it really lives up to that name, it means you can throw any waveform you want at it, and it will produce the mean square equivalent of it. Some flavors only work on a sinusoid. No harmonics, like, 60 hertz AC signal. Well, I guess since they tout its true RMS, it probably can handle complex waveforms. Well, it's back. Not so easy to get in. Well, I won't bore you with that. Plus, why am I putting them back on? I gotta go see if I can find another battery to try. Popped in a different battery. Let's see. Oh. Well, you know what that means. We have to open it up. I puzzled over how to get this device open for a while because I didn't see any fasteners anywhere. So I finally noticed that the standoffs that hold the back cover on have a slot in them. And it turns out that, yeah, you take these off. And hopefully, yeah, it slides out. Wow. They really packed this in. Oh, what are we looking at? Well, a big copper sheet on either side. I assume that's for shielding. It looks like it's just a piece of single-clad copper circuit board material. I don't even think it's coated with anything. It's just copper, kind of starting to corrode. And it's soldered on a couple points, completely covering the board below. Basically, this whole thing is made out of circuit board material. That's the back for where the batteries and fuses go. And of course, the two main boards here. And then the front is also more PCB. Wow. Man. It's kind of some origami action going on here. How do you even get in there to service this? Let's see if somehow you can pull these apart and fold. Oh, I see. Wow. This backboard that's kind of holding everything together has some connectors on it. So it looks like you need to pry these boards apart, and yeah, basically, yeah, it all kind of unfolds. Whew. Huh, it's two giant 40-pin chips in here. I don't recognize this one on the bottom or the maker's mark. I thought it was in H for Harris at first, but I'm not sure what that is. I don't know if you guys can see that, but this guy down here. One on top. That's an Intersil ICL7106. I bought a few of those way back in the day, and I played around with it in a little panel meter. That's a classic chip. But boy, there's a whole lot more going on than I was expecting to see in there. This thing is just crammed with parts, top and bottom. Multiple chips in there, a ton of resistors and capacitors. That's probably a precision wire wound resistor for the current ranges. Wow. I thought this was just some little cheapo kind of throwaway meter, but this is a lot going on in it. I'm really curious to find the manual now. Alright, I think that will deserve its own dedicated in-depth video, assuming I find more info about it. And let's see if we can get this thing working. Now, another item I forgot, actually I had left out in the garage. It is a Phillips oscilloscope that has seen better days. It's a model PM3214 according to the cover, which is all busted up. Appears to be dual channel 0 to 25 megahertz. Basic analog scope, probably from the 80s. Let's see, how does this? Push some buttons on the side that moves the arm handle there. It has a pouch up top. Don't know if there's anything in it. Yeah. Well, at least one probe. Apparently, it's the original Phillips. Let's see, is there a second one? Yeah, there is. Still in the bag. Oh, that's a fancy Ziploc bag. It has a metal zipper on it. This has some type of adapter, it looks like, and parts. Some caps, some, I forget what you call those, kind of breakaway integrated circuit tab, or pin thingies. Well, basically it looks like a little repair kit for the scope. I believe the previous owner said it didn't work. So let's plug it in and see what happens. Okay, this appears to be power down here. It's very clean. That protective cover did a really nice job. Looks like it's practically brand new. Well, it turns on, the power on LED is flickering. Not sure what that is all about. Illumination, it's probably supposed to, yeah, lights up the grid. That's nice. But yeah, we have no action. Oh, wait. Briefly, there's a brief moment of glowing on the CRT as I rotated the time division controls. Let's see. I'll be honest, it does feel kind of cheap. These plastic knobs and shafts, controls feel a little. At least I'm assuming these are plastic shafts because this focus control is, so they have give to them when you put some pressure on the knobs. So I imagine the market for this was more the hobbyist kind of thing. Oh, and the power light's not on anymore. So obviously it has problems. It is drawing current though. So I'm guessing it has power supply issues. That would account for all these problems. Well, it's a classic 80s scope. I may try to fix it. It might be something minor. Maybe it just needs a recap of the power supply. It's nice to have the original probes and such with it. I did a little bit of research online and quickly found out that this is a model 467, and it seems like it was pretty popular. There are a number of them on eBay, and there's plenty of info online about them, including the full owner's manual, which includes some basic troubleshooting and a full schematic parts list. Also, I stumbled across something on the EEV blog online forum. Somebody made the statement that the military used these and wanted to order a whole bunch more, but they couldn't secure the contract, and that's why they went with the Fluke 27 FM that you've seen me use so many times and so many other vintage electronics guys use, because, well, there's a ton of them on the surplus market. So my takeaway from that is this is actually a pretty respectable device. And then I looked at the schematic and, like, yeah, it's pretty well designed. I was close. That is the true RMS converter. It does have one. I thought it was a 536. It's a 636. I spent some time going over the schematic and kind of puzzling things out, because it looks a lot more complicated than I was expecting. There's the ICL 7106. That basically is everything you need to make a 0 to, I think it's 200 millivolt digital voltmeter and drive all the LCD segments. So ignoring all that, you could make it yourself a little panel meter with just that chip and that display and a few external components. So what's all this stuff for? Well, going over here is our input, and this resistor ladder, that's how you do your ranges. That's a classic way to do it with 9 mag, 900K, and so on. That gives you a divide by 10, 100, 1,000, the various ranges. And you got switches that route it differently for whether you're measuring resistance or voltage or current. This stuff is for the true RMS converter. Now, I looked up the data on that, and it is true RMS. You can feed a complex waveform into it. It also has capability to do AC plus a DC offset, which is something a lot of meters don't do. However, when you run this off a single power supply like a 9-volt battery, you can't. And that's why I was trying to trace out the input here, and I believe it does go through a capacitor at some point, which I think maybe through there. It strips off any DC component, which I believe is what my Fluke 27 FM does as well. It'd be cool someday to get a meter. I believe the one that Dave Jones, I think his name is, at the EEV blog, he designed his own meter, and I believe his does do DC offset plus RMS or AC component at the same time. Anywho, well, that's what all that is for. This stuff is for the peak hold feature, which is a neat thing. Like, say you want to find the peak surge current when you turn something on, or peak voltage across, say, a filter cap when you first turn something on to make sure you're not exceeding specs, you can use this feature. So then there's all this stuff down here, and there's a giant 40-pin integrated circuit here, and all this, some glue logic, some op amps. It took me a while to puzzle out what that was for. That is for the bar graph feature, I do believe. It's kind of a neat thing. The Fluke 27 also has it, but the refresh rate's kind of slow. So I'm curious to see how quick it is on this, because if it's fast enough and works well enough, you can use this for, like, doing an alignment in lieu of having an analog meter with a needle swinging back and forth. You watch this bar go up and down, and you tweak your trimmer cap or coil so that you get a peak on the bar graph there. So I'd really like to get this thing running. So with all this service info in hand, maybe. The one downside is some of these parts, like this in particular, would be really, really hard to source. If it's bad, I need a replacement. This is also, it's like a $50 chip, if you can find one. So, and honestly, it would be cheaper for me to buy another working meter for 20 bucks off of eBay than to go to any great lengths to fix this. But I will, in a separate video, do some basic stuff. So here's your 9-volt battery, your power switch. Let's just, make sure it's not something stupid like a wire broke or it's a broken trace. To make sure there's actually power going to the chips. Because, you know, I have multimeters. I don't really need another one, but this thing is kind of neat, so I'd like to get it working. Apparently there's also a flavor of it that uses a 7107 with an LED display, but that uses a lot more current, so it has like a rechargeable battery pack or an AC adapter that it works off of. Finally, yes, there were only a few items that I had missed. Finally, we have a classic Filco radio. It is from 1939. It's a model 3930, and it may look familiar to some of you longtime viewers because I restored one, oh geez, I don't know, what, 8, 9, 10 years ago. It's one of the first Integ radios I restored, and it was fun. I learned a lot doing it. It turned out really well. It's a well-performing radio, and I look forward to fixing this one up too. It is a slant front tabletop radio that covers, looks like 3 bands. 5 megahertz to 18 megahertz shortwave. Oh no, sorry, 2 bands. 5 to 18 megahertz shortwave, and the AM broadcast band, 550 to 1700, basically. Now, it might look a little rough, but this is pretty typical. There should be a plastic bubble cover over this, but the early plastic they use, they're always falling apart or missing. And these should be preset buttons, and they are also always disintegrated, shrunk, falling apart. They're nice, or should be nice, kind of cherry ruby translucent plastic. I hope reproductions are still available. I was able to get them for my other radio, but that was years ago. Hopefully I get them from Radio Days or some such. Covers 2 bands, 5 to 18 megahertz shortwave, and then the AM broadcast band, 550 to 1700 kilohertz. Let's see, this is tuning. The tuning action still works. I think this is a bit darker than it should be. I think maybe it got darkened from maybe some UV exposure. I believe you can get reproductions of the dial scale, but I'll leave this one alone. It's in pretty good condition. That's probably tone, volume, and oh no, that's power and tone. I think this is mode, which is probably broadcast, shortwave, and then maybe a phono input on the back. I'm not going to plug this in. This is a bit too old and crusty for me to just go ahead and plug it in, but we'll give you a look inside. It's in pretty good shape, but it does need a little help with the finish. Maybe I could get away with reflowing it, but there is some loss here. I'm not sure if there's any color on the finish or not. If there is, then that would kind of stand out. But that's what I was able to do with the other version, or the other instance of this I have, is I was able to spruce up the original finish. This you can just use black lacquer to go over that. The sides are in fairly decent shape, so I don't think it needs a full refinish. Here it is. It's a really weird design. I kind of get the feeling they were using up excess inventory. It's kind of a dinky power transformer, and it has a weird mix of outdated tubes. It has a 6A8, which is a pentagrid converter, or I think that's what they're called. It's a combination local oscillator and mixer tube. It's got 78, a 37, a 75, an 84, and a 41. That's a strange combination of tubes, because by this time this came out, 39, they had more advanced tubes. 75, 78, those are tubes that were more like, I think, mid-30s, but whatever, that's what they used. Let's pop one of these out. I don't think there are any octal tubes in this. Anyways, it is a neat classic radio. It does have one problem, though, which is it uses the dreaded rubber-coated wiring. so it probably needs to be completely rewired. And that includes the wires, I believe, coming out of the power transformer, maybe the audio output transformer, so it can be a little challenging to restore, but it is a nice little radio if you're kind of getting started. Anyways, I'm rambling. As always, who knows when I'll get to this stuff. I have to get back to the predicted TVs, but my sister saw this in a estate sale and picked it up for me, so I wasn't going to refuse. I hope you enjoyed this bonus part 3 to some recent spring finds. Thanks for watching.